Today we're going to be discussing word problems using our vertical motion model. So right here at the top, I have given you the vertical motion model, which is h, your height, negative 16t squared, that's acceleration due to gravity, so that never changes, plus v times t, so your initial velocity is v, t is time, plus s, your initial height. We're going to use this to set up an equation and then graph it. Two softball players are practicing catching fly balls. One player throws a ball to the other. She throws the ball upward from a height of 5.5 feet, so that's our initial height, that's going to be s, with an initial vertical velocity of 40 feet per second. So that is going to be our v for her teammate to catch. Write an equation that models the height h in feet of the ball as a function of time t in seconds after it is thrown. So that's just saying we want h equals negative 16t squared, that's gravity, plus vt, so our v is 40, so plus 40t, plus s, which is 5.5. Now that we have our function or equation, we want to graph it. So graph the function, label your axes. First, we want the axis of symmetry. So our equation for that is x equals negative b over 2a. Negative b over 2a. So we have to label our a, b's, and c's. So a x squared plus bx plus c. However, this time we're just using t instead of x. So our a is negative 16, our b is 40, and our c is 5.5. So we plug in those pieces. Negative b is 40 over 2 times negative 16. 2 times negative 16 is negative 32. The whole thing is negative. Double negative will make this positive 40 over 32, which is going to reduce to 1.25. So that is our axis of symmetry. X equals 1.25. Now we need to use that to find our vertex. So our vertex is the point when x equals 1.25, or in this case, we would say t equals 1.25 because we're using t instead of x. Vertex, we plug 1.25 up into our equation for our t's. So we have h equals negative 16 times t squared, so times 1.25 squared, plus 40 times t, so times 1.25, plus 5.5. Now, to evaluate this, we're going to use our graphing calculator, and I would recommend if you don't have a graphing calculator in front of you, you grab one and follow along as I do these operations so you make sure you know how to do them yourself. So we have negative 16, so negative 16 times 1.25 squared, so we're going to put the 1.25 in parentheses and then square it, plus 40 times 1.25, use the parentheses for times 1.25, and then plus 5.5. Enter, we get 30.5. So our vertex is 1.25, 30.5. That's our vertex right there. Y-intercept, if you remember, y-intercept is 0, c. So if we look up here, our c is 5.5, so y-intercept is 0, 5.5. So what I'm going to do now is I'm going to graph everything that we have so far. I'm looking at the values I have. I've got 5.5, 1.25, 30.5, and 1.25. So we have to really kind of determine our scale for our graph. So for my graph, I'm going to go every other is a 0.5. So every 4 is a whole number. This will make it nice and symmetric when I graph my line for t equals 1.25 right here. Now we really want to make sure we're labeling our axes. So down here, this is t for time in seconds. So then we remember that our x-axis is really our time. Then for our y-axis, we can go by every other is 5. So right here is 5. So every 4 would be 10. We can do this because our highest point is at vertex 30.5, so we only need to be able to get 30.5 on our graph, which would be right here. And then we can graph our y-intercept of 0, 5.5, so it's going to be right above 5. And then we can also use symmetry to get a point on the right side of our line of symmetry, right here at 2.5, 5.5. So right now we have a nice shape of our graph. We just want to get a little bit more detail, so we're going to make a table of values. We're going to have x, y. Always put your vertex in the middle. So we're going to have 1.25 in the middle, and then 30.5. Now if we look on either side of this line, our axis of symmetry, we have 1 and 1.5, so let's put 1 and 1.5. And then we have 0.5 and 2, so we want to do 0.5 and 2. We want to follow that scale that we made. Then we plug those into our calculator, and we get points on our graph. So just like we plugged 1.25 in for x, we're going to plug 1 in for x. We have negative 16 times 1 squared plus 40 times 1 plus 5.5. Press enter and we get 29.5. And then we'll also plug in 0.5 on our graph. So we have negative 16 times 0.5 squared plus 40 times 0.5 plus 5.5. And we get 21.5. We can put 29.5 here and 20.5 here, and then plot those points on our graph. And then we can connect these points with a nice parabola. And now we need to use this graph to answer some questions. So we have, if her teammate misses the ball and it lands on the ground, about how long was the ball in the air? Well, we know that right here, the ball has been in the air for 2.5 seconds and is at a height of 5.5. We got that from our symmetry with our y-intercept. So we know to be on the ground, it's going to be a little bit longer than 2.5 seconds, but not quite at 3 seconds or even 2.75 seconds. So we could say about 2.6 seconds. Now again, this is an estimate because we're using the graph. It's not going to be an exact value, but it's going to give us a good idea of how long that ball was in the air for. And then the last question, if her teammate catches the ball at a height of 5.5 feet, how long was the ball in the air? Now this is not an estimate because we actually know this one, and it's that point right there, so it is 2.5 seconds. So that would mean she'd have 2.5 seconds to get into position to catch the ball at a height of 5.5 feet. All right, if you flip your paper over, there are 2 more problems, and I am going to have you try these by yourself, but I have a couple things first. There is a typo. We want to change this 10 feet to 16. So if you could change that to 16, otherwise your graph will be very hard to graph. And then I'm just going to help you scale your axis, both your x and y axis. So here you want to go every other is 0.5. So similar to what we did in the first problem. And then on your y-axis, you actually want to go by 5s. So every line represents 5. And remember, this will be time, and this will be height. Follow the same steps that we did in the first problem. Use the vertical motion model. And then for your last problem, number 3, no typos, just make your equation. For this one, the scale of your graph, you'll scale your x-axis the same way we did before. So by every other being 0.5, so every 4 is a whole. And then your y-axis, you can scale it by 5s again as well, just like we did in problem number 2. All right, try these 2 problems, and I have the answer key so you can check them when you are done.